بسم الله الرحمن الرحيم. اليوم بإذن الله بنغطي الجزء الأخير من Unit 5, and if we are done we might go back to the homework to solve coding questions. Maybe we do it on EDA, so so we can write test benches also and make sure that these codes are working properly. طيب. فاضل لنا شغلتين في Unit 5 اللي هي ال User Defined Primitives and the Forever Loop. So user defined primitives, just a reminder about the primitive. البريميتيف احنا استخدمنا قبل كده system defined primitives. So we had system defined primitives اللي هي كانت الAND والOR الXOR XNOR. We had the NAND and NOR. We also had buffer F1, buffer F0, buff لا كان في nut F1 and nut F0. تمام. هذه system defined primitives that we saw before. The way we declare it, we just write the name of the primitive and then creating an instance of the and مثلا حنسميه A1. This is the instance name, and then we start by the output of this instant. If you defined مثلا عندنا input A and B, and we had wire أو output X, we should write X A B. Always remember that X or the first argument in creating this instance is going to be the output. تمام. فهذه system defined primitives. In Verilog we can also define primitives for our own. It's called user defined primitives أو تختصر في UDP. تمام. فكرتها انه if you have a function that you're going to use over and over and over again in your circuit, you can define it as a primitive, so it can be used in any of your modules. What are the features of this user defined primitives? الخصائص. أول شيء when you define a UDP, you don't use the keyword module. We're going to use a different keyword for defining, which is called primitive. فبداية الفايل, instead of writing module, we're going to write primitive. هذا أول شيء. طبعا module ends with end module. Primitive will end with end primitive instead. Okay, that's the first point. Second point, that these primitive can only have one output. And this output has to be listed first. Just like the case of system defined primitives, we list the output first. So in user defined primitives, that's going to be the same. We need to list the output first. ففي التعريف, when we write the primitive, we have first to declare the output signal, and it's going to be only one output. بالنسبة للinputs, you can have any number of inputs, ولكن when you call this UDP, you have to follow whatever order that you had for the input. And we're going to see example of that. Inside the primitive, we will use the keyword table and in table to write, we will see how to write an entire truth table inside this primitive, because your function is going to follow a specified truth table. يعني يكون عندك truth table and you want to implement this function in a primitive. So all you need to do is you write this truth table into Verilog, and we will see the syntax for that. Let's say, for example, you want to implement the function x, where x is equal to the sum of min terms 0, 2, 4, 6, 7. 0, 2, 4, 6 7. So in a truth table طبعا x is a function of, in this case x is a function of ABC, 3 inputs. So your truth table will have 8 entries. Entry 0 will have output 1, entry 2 will have output 1, entry 4 will have output 1, entry 6 will have output 1, and entry 7 will have output 1. The remaining output اللي هي 1 3 5, these will have output 0. تمام. if you check the syntax here, this is exactly your truth table. You have here the value of the inputs, and here is the value of the output. أهم شيء, when you define it, we're going to use the word primitive and then give it a name. And then here أهم شيء إنه output is listed first. So our output is X, and then we're going to list the inputs in order, which is A, B, and C. So also in your definition, you should follow this order. So output X, input ABC, and then write the keyword table and in table. In between table and in table, you're going to write your truth table. The way you write it is straightforward. Just write the inputs in order and then use a colon. After the colon, write the value of the output for this entry. So for 0, 0, 0, for ABC equals 0, 0, 0, your output will be 1. This is M0. For output 0, 1, 0, this is M2. We're going to have output 1. For output 1, 0, 0, which is M4. And then here we have M6 and M7. Everything else will have output 0. Also make sure that these are in order. 0, 1, 2, 3, 4, 5, 6, 7, exactly just as you write your truth table. Let's take another example that we write from beginning to end. Let's say you want to implement the function f of function of two inputs, f of ab. This is equal the sum of, let's say, 0, 2, and 3. And you were asked to implement this in a UDP. So first we write primitive. Let's call it circuit f. First we list the output, which is f, and then this is the input is AB. عرف output F, and we have input AB. Now use the keyword table and start listing your truth table. So 0, 0, colon, what's the output? Since M0 is in our function, so this
1.
is going to be 1, and then you use a semicolon at the end. 0, 1, this will be
0.
0 because M1 is not present in the summation function. بعد كده عندنا 1, 0 will give us 1, and 1, 1 will give us 1 as well. If you're done, use the keyword in table. And since this is all we have, we're going to finish the primitive with int primitive. This is just يعني straightforward implementation of your truth table. Okay? That should be يعني pretty easy and straightforward to do. علق. اوكي. طيب الان كتبنا البريمتيف how to use it in another module. تمام. عرفنا موديول سميناه declare circuit primitive. You're gonna define your input. اعتقد هذا it's a test bench, so you're gonna define your input as rigs. So we have inputs X, Y, Z, and I have one wire for the output W, just as you did with the module. ولكن wait, I think something is missing here. ثواني فين ال instance name? There should be an instance name here. I can't see an instance name. لأنه المفترض يكون اسم primitive زائد instance name, and then you list your output first, بعدها inputs in order. So in our circuit we had كان output X and the inputs are A, B, C. بالتالي the output W will be connected to X. The input X will be A, input Y will be B, and input Z will be C. Okay. Before we start coding or writing the code for the homework, let's test this one. If I cannot write an instance name, um, maybe user defined primitive do not need an instance name. I'm not sure. It doesn't even say that here. Which the input is declared. As follows. I don't see instance name. Maybe we don't need one. So let's check it in code when we're done with this part. طيب مشكلة ال user defined primitive that if you have a huge number of inputs, your table will be huge. يعني up to 4 inputs. تمام. You're gonna write 16 lines of for your table. يعني that's acceptable. يعني up to 4 inputs that's acceptable. After 4 inputs that becomes يعني extremely large. You need for 5 inputs you're gonna write 32 entries in your table. For 6 input you're gonna write 64 lines in your table, so it's gonna become hard to write. في بعض symbols that you can use to reduce the number of entries in your table, but you are still covering all cases of your input. You can use the symbol question mark. Question mark will mean this is 0, 1 أو unknown. So if your input is 0 or your input is 1 or if it's unknown حتعطيها value معين. مثلا إذا عندي ABC 3 inputs and I write 0 0 question mark. تمام. وهذه تعطيني 1 مثلا. معناها انه if your input is 000 او 001 او 00 unknown, your output is equal to 1. تمام. فاختصرت 2 entries of my table. Instead of writing 8 I can write 7 because these two cases are going to be the same. Same for the symbol B, ولكن B does not cover the unknown. So if your input is unknown, you're going to have an unknown value for the output. ولكن if you want to cover the unknown value, use the question mark. So these two are the same. Note that these two symbols cannot be specified in an output field. مثلا هنا you cannot use question mark and you cannot use the value of B. Okay, this is all. These symbols can only replace any bit of your input, but not the output. We have two more symbols that can be used for the output. Minus, the minus symbol, that means there is no change in state value. دام في كلمة state معناته احنا بنتكلم عن ايش؟ نتكلم عن sequential circuits. زي مثلا عندك الدي flip flop مثلا، الدي flip flop له input D and you have an input for the clock. you can write مثلا انه if اذا مثلا نخليها clock and then d, so you can write 0, you can write 0x. تمام. So if clock is 0, you can say that the output is no change. الاوتبوت طبعا عندنا اللي هو q. No change means just store the value of q. You don't need to change it. طبعا هذا فقط في sequential circuit، لانه في الcombinational circuit ما عندنا شيء اسمه hold. You change the input, the output changes. ولكن في sequential circuit لا. Sometimes you need to hold the value of the output. يبقى عندنا symbol star, that mean any change, any value change in the signal. 0 1 x, for any change just بعد كده تحدد الاوتبوت، تبغى 1 تبغى 0 تبغى hold. Okay, so these symbols will help you reduce the size of the table. Let's take an example. This is a primitive UDP OR. We have one output and we have two inputs A and B. So if A equals 0, B equals 0, I want the output equal to 0. Now if A equal to 1, whatever the value of B سواء كانت 0 1 أو unknown, let the value out equal to 1. Because sometimes if you use an OR primitive, the system defined primitive OR, and one of the input is unknown, it's going to directly give you an unknown value for the output. ولكن هنا لا، معناه when we used a question mark, that means if we have if this is 1 0 أو 1 1 or 1 unknown, all these cases give me 1 at the output. Otherwise you should define it. تحط انه 1 0 يعطينا 1, 1 1 will give us 1, and 1 unknown will give us also 1. So instead of writing these 3 lines, you can use the question mark symbol to cover all these cases. Same for unknown value for A, but we have B equal to 1. We want the output equal to 1. In case of 0 unknown or unknown 0, let the output be unknown. Okay. فهذه السيمبلز فكرتها انك تقدر تختصر many cases in your design. If you remember مثلا ال truth table of the encoder, if you have خلينا نقول 8 to 3 priority encoder. 8 to 3 priority encoder, we should have عندك 8 inputs, so you should write how many lines for an 8 to 1 priority encoder?
64
8 to 3
ولا
6 لا
128
اكثر,
بعد
256 lines.
الله.
But do you actually need these 256 lines in a priority encoder? لا. كان عندنا truth table حتى كتبناه في we designed some encoders in CEN211. We had D7, D6, D5, D4, D3, D2, D1, D0. وعندنا الاوتبوت خلينا نقول اللي هي A2, A1, A0. تمام. Just ignore the valid signal for now. Now if D7 equal to 1, the output should be 1 1 1 regardless of all these values. من هنا إلى هنا you need to write 128 lines that have D7 equal to 1 and you have the same output. So all these in your truth table are don't cares. In the entry of primitive, if you want to write it in Verilog, you can write 1, and then either the value of B B B B B 1 2 3 4 5 6 7 8 B 1. all B's will give me 1. او انك تغير البيز الى question marks in case you want to include the unknown value. يعني if any of these values unconnected او انها unknown جايتك من output وكانت unknown, you can ignore that as well by using question marks. الان this one line اختصر لك your truth table by 128 lines. Same for this case. If this is 0 and this is 1, I don't care about all the values of D5 to D0 because if D6 is 1, I want the output to be 110. معلش هذه الان in a priority encoder طبعا ما تقدر تكتب priority encoder as a primitive. تمام، انا حطيتها example فقط انك بعض التروث تيبل تكون ضخمه وتقدر تختصرها. لو تذكروا البريميتيف have only one output. تمام، ف فقط حطيت example how كيف تختصر التروث تيبل، او انه this is one example of a truth table that we already did where we have يعني so many shortcuts. تمام، فبلاش بلاش الاوتبوت. I'll just write how to write this input into the table. For this one will become 0 1 and then question marks for the rest, whatever output you want for your circuit. تمام. Again, don't get confused. This example cannot be implemented in a user defined primitive. ليش؟ لأنه شرط ال UDP إنه يكون عندك only one output. Okay, so in table لما تستخدم ال keyword table after the colon only one field that can يعني be inserted here. يا إما 1 0 أو hold. Okay, note that. هذا فقط example إنه بعض ال truth table can be shortened by يعني a huge amount. ف instead of writing for an 8 to 3 priority encoder, instead of writing 256 lines for your truth table, you can actually write it in 8 lines. Only 8 lines to describe your whole priority encoder because we are using a don't care value. Okay. This is for a user defined primitive. One last part in unit 5 is about the forever loop. So يعني from the name, a forever loop is equivalent to writing مثلا while 1 أو while true, which is creating an infinite loop. Usually when you code it in Java or whatever, you don't want to have an infinite loop. ولكن in Verilog sometimes we want an infinite loop. Why? This is mainly used for generating the clock. يعني اعتبروها introduction to unit 6 where we talk about when we talk about sequential circuits. We need all sequential circuit will have clock as an input, and we know that clock circulates between 0 and 1 يعني indefinitely. if you want to generate a clock, you can do it by writing مثلا delay by 5 clock equals 0, delay by 5 clock equal 1, delay by 5 clock equals 0, and so on. طبعا you're gonna need يعني as long as you يعني you need to repeat these two lines as much as you need for simulating your circuit. ولكن an easier way to do it is to make or to use a forever loop. Here we're going to define clock as reg, and then in an initial end statement we will write clock equals 0 at the beginning. So start with clock equals 0. This is 0 and this is 1. Clock equals 0, and then forever delay by 10 units, and then make clock equal to not clock. So after 10 time units, the value of clock is equal to 0, not 0 is equal to 1. بالتالي let clock equal to 1. اوكي الان احنا هنا. بعدها حنرجع الى the same sentence because this is a forever loop. Delay by 10 time unit, make clock equal not clock, that's 0. Come back again, delay by 10 time units, make clock equal not clock, that's going to be 1. Delay by 10, 0, delay by 10, 1, delay by 10, 0, and so on. And you can easily see that this output signal is a clock signal. طبعا of course inside your uh, test bench, if you're simulating a if you're simulating a sequential circuit, you need a clock signal. But this is how you do it. Okay, so this can be used as a clock generator. And you can also customize a time where the clock is equal to 1 and the clock is equal to 0. Like in this example, it says create a clock generator in Verilog, which generates a clock signal that initially goes to 0 for 15 nanoseconds and afterwards goes to 1 for 5 nanoseconds. معناها I should have a clock that looks like this تقريبا يعني. Okay, so from here to here that's 15 nanosecond, and then from here to here is 5. بعد كده from here to here is 15. This is 5 and so on. We can still use a forever loop for that. Define your clock as a reg, and then inside your initial uh, begin end statement, you can start with clock equals 0, and then delay by 15 time units. إذا يبغى 15 nanosecond, you need to use a time scale 1 nanosecond, and يعني to whatever precision you want. Let's say 0.1 nanosecond. So this will go for 15 nanosecond, and then make clock equal to 1. بعدها delay by 5 time units, make clock equal to 0. Since you reached the end of the forever statement, that means you're gonna come back. So when you come back, first you're gonna delay by 15 time units, make clock equal to 1, delay by 5, clock equal to 0, and so on. Okay, and these values can change. We can ask you to implement مثلا for 10 and 15, clock should go to 1 for 10 nanosecond and 5 nanosecond when it's 0, and so on. So you can make all different يعني shapes of signals using a forever keyword. How to write it? You just write forever, and that's it. If it's only one statement that you are executing, you can just write it right away. If you have a couple of statements, just use forever begin end. طيب, to summarize unit 5, we covered 3 topics mainly. First is modeling styles. These are things that we did before, ولكن in a more structured way. To understand the modeling styles in Verilog, we had structural modeling, we had behavioral modeling, and we have data flow modeling. And we talked about how to create a test bench for your modules, how to test or how to provide inputs to your modules, and how to read the outputs. This is to ensure that your circuit is functioning correctly. Lastly, what we covered today is user-defined primitives. This is just like system-defined primitives, ولكن if you want to define your own functions, you can do that by using the keyword primitive and the keyword table. Lastly, the forever loop, which is just a way to write any infinite loop that you want. Okay, this is the end of unit 5. Inshallah, next Sunday we should start unit 6, or maybe, yeah, we'll start unit 6, and probably in the tutorial session we will see if we have a tutorial for unit 5. We're going to go through it, and also you can expect a homework during the weekend which will needs to be submitted next Thursday. um, we'll be left off with one last homework about unit 6 inshallah. طيب، في أي سؤال؟
هذه ثار.
تفضل.
الفوريفر اللي قبل شوي نستعمله جوا التست بنش ولا الديزاين العادي الموديول؟
inside the test bench، لأنه you're not going to generate a clock inside your module. يعني متى تحتاج الكلوك inside your module you're gonna generate the clock input. هيكون عندك clock input. Remember that module means you're creating the block diagram of your circuit. You're not testing. You cannot pass inputs أو read outputs out of your module. You're just describing what your circuit is doing. هيكون عندك a clock as an input, and you write مثلا انه when clock equal to 0 مثلا x equal to 1, when clock equal to 1 x equal to كذا, just describing your module. تمام. ف when you write a module يعني تخيل انه هذا result of your module. هيكون عندك number of inputs and number of outputs. You don't generate the value of the input, or you don't generate the value of the output. You just write a description of how to use your inputs to generate these outputs. لكن ما تعطي قيمة ل A وقيمة ل B وقيمة ل C. And you don't read a value for X and a value for Y. You just describe what X is depending on your inputs and what Y is depending on your outputs. If you want to generate any type of input, يعني أبغى A0, B1, C0, and I want to check the output, this is where you write your test bench. That's what the test bench is for. test bench حيكون بهذا الشكل. تمام. هذا الانبوت generator which will connect to your module, and then at the output we're going to connect wires to read the signals that's coming from your output. Okay, for forever loop to create a clock, this is for testing. You don't write a forever loop inside your module. طيب, let's go to I think we wanted to check something before we do the homework. Let's test the primitive. اي صح, بنشوف اذا البريمتيف يحتاج الى if the primitive needs an instance name. تمام. So let's write a small primitive. Let's say primitive circuit T, which will have FAB as input, or F the output and AB are the input, and primitive. So we have output F, we have input AB, and then we use the keyword table and write 0, 0 will give us 1. 0, 1 will give us 0. 1, 0 will give us 1, and 1, 1 will give us 1. At the end, we write in table. Okay, so in our test bench, we'll have rig for A and B. We'll have a wire for a wire for F. Then let's write circuit T, right? and we're gonna pass if a b. So initial begin end module. Let's say a is equal to 0 and b is equal to 1. Delay by 1 time unit. Let's display the value of f is percentage b and then f. Okay, let's see how it works. So the value of f is 0. Okay, we don't need, looks like we don't need to have an instance name using system defined primitives. Can I write and let me try that. Tenant and associated notice not found in Sage library. Does this guy does not have system defined primitives? I think they don't. ولا مثلا لازم اكتبها in a separate module. Anyways, what we wanted to check is the UDP. It seems like you don't need to have an instance name for that UDP. You just can just write the primitive name and then connect your output first. بعدها you list all the inputs. So whatever was in the slides was correct. تمام. هذا بالنسبة للprimitive. Let's change the value to make sure that this is working properly. If a equal 1 and b equal 1, we should have f equal to 1. Yeah. So f is equal to 1, then that's fine. Okay. Let's we had one code missing from the homework اللي هو كان الشيفتر صحيح. So let's write that module, let's call it module shifter. It had two inputs اللي هي a number A, the value shift N, which is the serial input, and then we have an output. We have an output Y. Okay, so I have input. Was it? I think this was custom, right? So parameter N, we started with N equal to 8, and then we need to declare A as N minus 1 to 0. This is A. And then we have 1 bit for the serial N. And we'll have output same from N minus 1 to 0. Okay, we called it Y. And we were asked to implement this using loops. Now, this is a shift left, so let's write here as a comment what's going to happen when we shift left. So when your input come, I want the output shifted left by 1 bit. Yeah, we want to shift left by 1 bit and insert shift N into the least significant bit. بالتالي y of, خلينا ناخذ الاكزامبل اللي هو عن 8, so we use numbers and then we can rewrite it in terms of n. So I want y7 to 1 equal to the input. Y7 to 1 should take a from 6 to 0. صحيح. y7 to 1 should take a6 to 0, and then I want y of 0 to take in shift n. Okay. طيب. So always at a, whenever a changes, a أو shift n. Always at a or shift n, since we need to do it in loops, so we need to define an integer I to use it as a loop counter. طيب. Always at a and shift n. Let's write the for loop for I starting from 0 going to I to n minus 2, and we're going to see y I plus plus.
دكتور
هلا.
مو لازم نحط اف شيفت.
ما انطلب في السؤال انه يكون في signal to control the shift. يعني you give an input اعطيني الاوتبوت shifted right away. فما كان في if you add it that's fine. if you add the signal that's fine. ولكن السؤال ما طلب. So we don't need that. هي حتكون اضافه if statement. ولكن الفكره من السؤال انه how to write this loop. طيب في البدايه we have y of 0. This is going to be outside the loop. Y of 0 will take in the value of shift n او serial n. ناس ايش سميتها. تمام. So this will take shift n. طيب inside the loop احتاج y of I plus 1 to equal to a of y. معلش a of I. Okay. in the first loop this is going to translate to y1 will take in a0. اول شيء اللوب هذا حيمشي كم اذا كان عندك n equal to 8. This will go from I equal 0 up to I equal, sorry this should be my soon I think. For I equal 0 to I less than 7, that means I will go from 0 to 6. Okay. I will go from 0 to 6. In the first loop, first iteration, y1 will take a0 and then oops, 3 4 5 6. Second iteration, y2 will take in a1. Third iteration, y3 will take in a2, and then y4 will take a3, y5 will take a6, and then y6 will take in a7. في شيء غلط.
ياخذ A4 يا دكتور الواي 6
2 3 4
واي 5.
ايه بس اوكي y5 f5 0 1 2 3 ايه صح تمام. ف y1 will take in a0. ف a6 كده في 2 bits انحذفت. Wait, this will go from 0 to 6. This will go from 0 to 6. في line ناقص 0 to 6. This is 7 iterations. Okay. So I need also y7. So y7 will take a6. صح sorry 7 iteration مش 6. You go from 0 to 6. This is 7 iterations. تمام. So first iteration y1 دام 7 iterations, this will start from 1 to 7, and A will go from 0 to 6, and this is what we want. This is exactly what we want here. 6 to 0 will be assigned to 7 to 1. يبقى عندنا y0 هذه تكون خارج اللوب. Okay, so we can test it. We will have a reg for A. طبعا هنا لازم احدد 7 to 0. هي الفكرة انه if you want to change this code, all you need to do إذا تبغى مثلا بدل 8 bit تبغى 16, you can just write 16, and then this will be a 16-bit shifter. If you want it 4, you can change it. So let's make it 8-bit. We have a reg for A, a reg for shift N, and we have an output Y. This is not going to be declared here. So shifter S1 will take in A, shift N, and Y. Initial, let's test that A is equal to 8-bit of a random number. 1, 2, 3, 4, 5, 6, 7, 8, and let shift N equal to 0. Okay, and the value of Y equal to Y. Let's check if we have any errors. Okay, we should have errors. Not a valid left hand side, Y of 0. Huh? Why not? Okay. Y of 0 is not valid left hand side of a procedural assignment. I just did that yesterday. شو المشكلة؟ shift in. Okay. Output rig. طيب, we still have undeclared assignment Y. We don't have Y. We have small y. Okay. So A was 11001010. معناه when we shift left by 1, inserting 0, we should get 100101010. Check this number with this, and you'll find it's exactly the same. الآن إذا غيرت shift in إلى 1, the output should become like this. Let's check 10010101. 10010101. So your module is working fine. Change that to 4-bit. Come here, make it 33. Change that to 4-bit. So 1001, and we want to shift it left by 1, inserting 1. This should give us 0011. Run it. You get 0011 right away. All we did is just fixed or change the value for parameter n. Okay. So this is the solution for the question that we didn't solve in previous class. We're out of time, so في أي أسئلة أخرى؟